Chapter 11, Lesson 4, Mean Absolute Deviation. You will be able to find and interpret the mean absolute deviation for a dataset. You have used the interquartile range to describe the spread of a set of data. You can also use the mean absolute deviation. The mean absolute deviation of a set of data is the average distance between each data value and the mean. The table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. So the first thing we need to do in order to find the mean absolute deviation is to find the mean. To find the mean, we have to add up all the values and divide by the total amount of data there are. So let's go ahead and add up the data values. 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. And we're going to divide that by 8 data values. Okay. When we do that, add them all up first, hit equals, then divide by 8, and we get a mean of 64. So what we're going to do now is we're going to take that mean and subtract it from each value, and then take the absolute value of it. Now what I want you to do is compare the mean and each value and see which one's bigger. So our mean is 64 and our first value is 58. 64 is bigger, so I'm going to write that first. 64 minus 58. I'm going to put that in absolute value bars. Well, 64 minus 58 is 6, and the absolute value of 6 is 6. Now look at your mean in the next value. So we did 58. Now let's look at 88. 88 is bigger, so I'm just going to write 88 first. 88 minus 58, and again with absolute value bars. 88 minus, I'm sorry, not 58, 64. 64 is the mean. 88 minus 64, absolute value of that is 24. Move on to your next value. We have our mean of 64 and 40. 64 is bigger. I will write that one first. 64 minus 40 is 24, and the absolute value of that is also 24. Our next value is 60, so the absolute value of 64 minus 60, again putting the mean first because it's larger, so 64 minus 60 is 4, and the absolute value is 4. Next we have 72, which is larger, so absolute value of 72 minus 64. Well, 72 minus 64 is 8, and the absolute value of 8 is 8. Next we have 66, which is larger, so 66 minus 64 is 2, and the absolute value of 2 is 2. 80 is larger, so absolute value of 80 minus 64 is 16. The absolute value of 16 is also 16. Last value is 48, which is smaller, so absolute value of 64 minus 48 is 16. So now that we've found the absolute values of all these, we're going to conduct another mean, but this time of these values. So let's go ahead and add these values together. 6 plus 24 plus 24 plus 4 plus 8 plus 2 plus 16 plus 16. Again, there are 8 of them, so I'm going to divide by 8. Okay. Add everything in the numerator, hit equals, then divide by 8, and we get 12.5. So really what we're doing is we're taking two averages. We find our means. We find the first mean, subtract each data value from it, then we find the mean of those new values. Okay? And the result is our mean absolute deviation. So let's describe what that means. The mean absolute deviation is 12.5. This means that the average distance each data value is from the mean is 12.5, and we're talking about speed of roller coasters, so miles per hour. Let's go ahead and look at letter B. The table shows the speeds of 10 birds. Find the mean absolute deviation of the data. Round to the nearest hundredth. Describe what the mean absolute deviation represents. So again, we're going to first start off by finding the mean. So let's add all these values together. 88 plus 77 plus 65 plus 70 plus 65 plus 72 plus 95 plus 80 plus 106 plus 68. This time there are 10 values. So let's go ahead and divide that by 10. When we do that division, or we add everything up and do that division by 10, we get a value of 78.6. Again, we're going to take each number and subtract it we're going to subtract it from the mean. But again, comparing and putting the larger number first. So we have 88 and 78.6. 88 is larger, so absolute value of 88 minus 78.6. 88 minus 78.6 is 9.4, and the absolute value is also 9.4. Next number. 78.6 is larger than 77, so we will put that number first and subtract and take the absolute value. When we do that, we get 1.6. Next value is 65, which again is smaller than the mean, so 78.6 minus 65, and the absolute value of that gives us 13.6. 70 is smaller, so 78.6 minus 70, and take the absolute value of it, and we get 8.6. 65 is smaller, so 78.6 minus 65, take the absolute value, and we get 13.6 again. Our next value is 72, which is smaller than the mean, so 78.6 minus 72, and it's 6.6. Our next value is 95. Which is larger, so 95 minus our mean of 78.6, and take the absolute value, we get 16.4. 80 is also larger, 80 minus 78.6, take the absolute value, and we get 1.4. 106 is larger, 106 minus 78.6, absolute value. Subtract those and we get 27.4. Last one is 68, which is smaller. So absolute value of 78.6 minus 68. Take the absolute value and we get 10.6. I'm going to make this smaller so we can see it all on one shot here. There we go. All right. So now we found the mean, which is 78.6. We subtracted it from each data value, of course finding the absolute value of those numbers. And we have a new set of 10 numbers. So let's go ahead and add those numbers together and divide by the total data value. Let's find the mean. 9.4, let me go ahead and make this smaller already. 9.4 plus 1.6 plus 13.6 plus 8.6 plus 13.6 plus 6.6 plus 16.4 plus 1.4 plus 27.4 plus 10.6. Let me make sure I have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide them by 10. When we take those data values, add them up, then divide by 10, we get a value of 10.92, which is the mean absolute deviation. And let's just jot down what that means. The mean absolute deviation is 10.92. This means that the average distance each data value is from the mean is 10.92. Again, we're talking about speed, in this case of the fastest birds. So it's in miles per hour. We can also compare variations. We can compare the mean absolute value for mean absolute deviations for two data sets. A data set with a smaller mean absolute deviation has data values that are closer to the mean than a data set with a greater mean absolute deviation. Also, you can say the data set with the greater mean absolute deviation is more spread out. The top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundredth. Find the mean absolute deviation for each set of data. Round to the nearest hundredth, write a few sentences and comparing their variation. So we are going to do two sets of mean absolute deviations and compare them. So let's start with the top 5 salaries. First thing we're going to do is find the mean. 33.00 plus 24.29 plus 22.60 plus 20.63 plus 16.50. Let's make this smaller. There are 5 data values. So we're going to go ahead and divide that by 5. And we get the mean to be 23.4. This is for the top 5 salaries. Let's go ahead and subtract each data value from the mean. 33 is larger, so 33.00 minus 23.4, and the absolute value is 9.6. 24.29 is our next value, which means 24.29 is first, it's larger, minus 23.4. Absolute value of that is 0.89. Do not round any values until the very end, if need be. Our next value is 22.60, which is less than 23.4, so we're going to put 23.4 minus 22.60, absolute value bars, and that is equivalent to 0.8. Next is 20.63, so 23.4 minus 20.63, absolute value is 2.77. And lastly, 1650. So 23.4 minus 16.50, absolute value is 6.9. Let's make this a little smaller to give ourselves more room. Now we will take these values and find the average. 9.6 plus 0.89 plus 0.8 plus 2.77 plus 6.9 divided by 5 values. And that equals 4.19. So the mean absolute deviation for the top 5 salaries is 4.19. Now let's take a look at the bottom 5 salaries. Let's go ahead and add those up and divide by the total amount to find the mean. .45 plus 0.44 plus 0.43 plus 0.41 plus 0.41. Again, dividing by 5 numbers. When we do that division, we get a mean, we get a mean of 0.43. This is for the bottom 5 salaries. Let's go ahead and subtract each data value from the mean. Absolute value, 0.45 minus 0.43 equals 0.02. Next, 0.44 minus 0.43, absolute value is 0.01. Absolute value of 0.43 minus 0.43 is 0. Absolute value of 0.43 minus 0.41 is 0.02. And last one, 0.43 minus 0.41 equals 0.02. Now that we have those data values, let's find the average or mean of those ones. 0.02 plus 0.01 plus 0 plus 0.02 plus 0.02 divided by 5 values. When we divide that, we get 0.01. Rounded to the nearest hundredth, as it said to. Okay, so we found the mean absolute deviation for both. The next instruction says to write a few sentences comparing their variation. So here's what we can say. The MAD for the bottom 5 salaries, which is the data on the right, is much less than the MAD for the top 5. salaries. This means that the data for the top 5 salaries is more spread out. The table shows the running time in minutes for 2 kinds of movies. Find the mean absolute deviation for each set of data, round to the nearest hundredth, then write a few sentences comparing their variation. So let's do another one. Let's start with comedy. Let's find the mean. 90 plus 95 plus 88 plus 100 plus 98. Divide by 5 values. We get a mean of 94.2. And again, this is for the comedy. Now let's take the mean and subtract each data value. 94.2 minus 90, absolute value is 4.2. 95 minus 94.2, our mean, gives us 0.8. 94.2, our mean, minus 88, absolute value, equals 6.2. 100 minus the mean, 94.2, take the absolute value, we get 5.8. And last but not least, we have 98 minus 94.2, take the absolute value, and it's 3.8. Now let's find the average of those numbers. .2 plus 0.8 plus 6.2 plus 5.8 plus 3.8, divide by 5. Which means the mean absolute deviation is 4.16. Now let's find the data or information for drama. Find the mean by adding up all the values. 115 plus 120 plus 150 plus 135 plus 144 divided by 5. Which gives us a mean of 132.8. Now take each data value and subtract it from the mean, finding the absolute value. 132.8 minus 115, absolute value is 17.8. Absolute value, 132.8, which is the mean, minus 120. Absolute value is 12.8. Absolute value of 150 minus 132.8 is 17.2. Absolute value of 135 minus 132.8 is 2.2. And one absolute value of 144 minus 132.8 is 11.2. Let's find the average of these values. $17.8 plus 12.8 plus 17.2 plus 2.2 plus 11.2 divided by 5. And the mean absolute deviation is 12.24. So let's write a few sentences comparing them. Remember, comedy is on the left, drama is on the right. So let's first state that the mean absolute deviation of the running times of comedies is less than the running times of dramas. And since the drama mean absolute deviation is larger, we can say that the data for the drama running times is more spread out.